Welcome you all. In this session, we are going to discuss in detail about the magnetic leakage calculation in induction machines. Magnetic leakage calculation. Leakage factor or the leakage coefficient is going to be calculated. You are going to find that. All the flux produced by pole will not pass through the desired path. That is, air gap sum of the flux produced by the pole will be leak away from the air gap. The flux that pass through the air gap and cut the armature is the useful flux. So we have useful flux and other flux. So useful flux are those flux which are utilized for the machine to make the machine run in a proper direction. We call them as useful flux. So here phi p is equal to phi plus phi l. The other flux, leakage flux, phi l is the leakage flux. As the leakage flux is generally around 15 to 25 percentage of main flux produced. So phi p is equal to phi plus 0.15, that is 15 to 25 percentage of main flux, leakage flux. Total flux is the flux generated plus the loss. Okay, so this term we can take it as what? The leakage coefficient LC. And the flux that leaks away from the desired path is the leakage flux, where LC is the leakage factor or leakage coefficient, lies between 1.15 to 1.25. The magnitude of flux differ different parts of magnetic circuit. Leakage reactance is equal to 2 pi f into inductance. This is the leakage reactance for a polyphase machine. So which is again expressed as 2 pi f into flux linkage divided by current. Useful flux. It is a flux that links with primary and secondary winding and is responsible for transferring the energy electromagnetically from primary to secondary side. The path of useful flux is in the magnetic core. The second flux is the leakage flux. It is the flux that links only in primary or secondary winding and is responsible in imparting inductance to the winding. The path of leakage flux depends on the geometrical configuration of coil and the neighboring iron paths masses. So useful flux, it cooperate with primary and secondary winding and it is responsible for the energy transformation from primary to secondary. But leakage flux, they won't cooperate in the energy transmission from the primary to secondary, so they flow on the other parts. Okay, so either on primary or on secondary, like that. So they are, we call it name it as the leakage flux. So here comes the phasor diagram of flux linkages. So here in this phasor you can see the flux, the leakage flux, the current, the voltage and the EMF induced. So the effect of magnetizing current and its effect of power factor can be understood from the following phasor diagram. So phi 1 and phi 2, as it increases, what happens? The magnetizing current increases, what happens? You can see the magnetizing current and power factor being very important parameter in deciding the performance of induction motor. The induction motors are designed for optimum value of air gap or minimum air gap possible. So this is how the leakage flux are calculated and how the leakage flux are minimized. Thank you.